This video presents structural security and perimeter defense guidelines, offering an architectural breakdown of barrier categories, hardware specifications, and installation standards for the physical protection professional. Physical barriers can be categorized into 4 types. Structural and roof barriers enhance building envelopes. Fencing and perimeter walls offer demarcation and delay. Vehicular blocking barriers include active and passive systems. Lastly, symbolic and natural barriers provide psychological deterrence and environmental blending. The whole effect maximizes delay below the roofline. Enhancement techniques involve upgrading roofs with embedded screens, insulation, and reinforced concrete. Barriers below the roof create a confined space trap, limiting leverage and drastically increasing an adversary's challenge. Chain link fencing provides essential baseline demarcation. It acts as a visual deterrent. The selvage or wire end can be knuckled for a closed loop or twisted/barbed for sharp points. The mesh is interwoven and coatings are typically zinc, aluminum, or PVC/polymer. Post installation relies on mathematical precision. Line posts are spaced a maximum of 10 feet apart. Terminal posts must be braced diagonally if no top rail is used. The hole depth follows a formula, and the diameter is 4 times the largest cross-section of the post. Standardized dimensions prevent under-equipped perimeter defenses. Fabric specifications require a minimum of No. 9 Aruban Florins wire and a maximum mesh opening of 2 inches. Ground clearance is typically 2 inches. Top guards, placed at a 45-degree angle, can be outward, inward, or V-shaped. Alternative fencing options include expanded metal, which is tough and less expensive than perforated metal. Cable system fencing uses high-strength cables. Wooden fences are for low-security applications. Decorative fencing balances aesthetics with security, often using materials like brick and stone. Active deterrence elevates standard fencing. Electric security fencing consists of a close wire grid, offering either a live wire pulse or a monitored system that triggers an alarm. Barbed and razor wire rules dictate a minimum height of 7 feet and posts spaced less than 6 feet apart if used as the main fence. Blocking barriers control access and mitigate vehicular threats. Passive barriers, such as fixed bollards and jersey barriers, are fixed in place. Active barriers, like retractable bollards and rising wedges, regulate access at checkpoints and require an attendant or electronic system. Bollard effectiveness relies on deep subgrade engineering. Spacing should be between 36 and 48 inches. To comply with 8A, bollards must not exceed 38 inches in height. Typical heights are often kept below 30 inches to reduce visual intrusion. Active blocking barriers demand rigorous maintenance. Wedge systems, which operate hydraulically, must be attended at all times. Retractable bollards, operated manually, electrically, hydraulically, or pneumatically, require high maintenance and defined operating procedures and testing protocols. Fixed barriers must overcome the vulnerability of pure mass. Jersey barriers, typically 5,700 pounds, are ineffective against vehicular attack if simply placed on the ground. They must be embedded. Engineered planters must also be secured with rebar dowels or steel pipes for protection. Vehicle crash ratings evaluate a barrier's ability to stop a 15,000-pound test vehicle at specific speeds. Ratings like K4, K8, and K12 correspond to speeds of 30, 40, and 50 miles per hour, respectively, and are mapped to ASTM ratings M30, M40, and M50. Symbolic and natural barriers use subtle psychological signals. Elements include landscaping, curbs, and terrain changes. These barriers, often disguised as aesthetics, help control movement and make individuals uncomfortable when straying from designated pathways, aligning with CPT principles. A unified perimeter involves an interdependent matrix of delay, deterrence, and denial across 4 layers. Layer 1 uses symbolic and natural barriers. Layer 2 employs active and passive blocking barriers. Layer 3 utilizes chain link fencing, and Layer 4 includes structural roof enhancements to maximize delay.